Hello, I'm Robert Zubrin. I'm president of Pioneer Astronautics, and I'd like to talk to you for a couple of minutes about our aerostat gas generation system technology. The aerostat gas generation system works by dissociating ammonia, NH3, into nitrogen and hydrogen. Okay, we can use a simple thermal catalytic dissociation system to split ammonia into a gas that's 1/4 nitrogen, 3/4 hydrogen. It collectively has a molecular weight of 8.5, okay, which means that for every unit of air, which has a molecular weight of 29, this gives you 20.5 units of lift. That compares to helium with molecular weight 4, gives you 25 units of lift. So the helium gives you slightly more lift per unit mole, but it costs 50 times as much. That's right, 50 times as much. And the canisters that are needed to transport it at high pressure, K bottles, weigh 40 times as much. Okay, much too much to take up in a balloon and use to refill a balloon as it starts to leak gas. Whereas this technology, okay, the ammonia stores at very modest pressure, comparable to propane. It can be stored in propane type cans with a very high ratio of fluid to the tankage weight. Okay. And then also ammonia can be obtained cheaply, and if you're doing a campaign around the world, it can be locally sourced instead of being needed to be transported from the United States. Now, compared to dropping ballast, there's an enormous advantage because let's say you have a balloon that leaked 4 kilograms of helium. Well, that displaces 29 kilograms of air. You've lost 29 kilograms of lift. If you want to compensate that by dropping ballast, you'd have to drop 29 kilograms of ballast. Okay. On the other hand, it would only take 8.5 kilograms of ammonia to generate lift gas to replace it. So instead of requiring 29 kilograms of ballast, you can do it with 8.5 kilograms of ammonia. And instead of the floating mass of the balloon changing by 33 kilograms, which is the lost helium plus the ballast, in our case, it only changes by the lost helium 4 kilograms. So you're using less than a third the consumable mass to stay afloat, and your excursion of your altitude caused by a change in the floating mass will be 1/8 as much. So there's a tremendous advantage to it. Now, under funding from NASA, Pioneer Astronautics built what we call the gas replacement system, which is the prototype for the aerostat gas generation system. This was designed to replace the gas lost by a very large, I believe, 40 million cubic foot helium superpressure balloon operating in the upper stratosphere. Okay, and in order to do that, we need a capability to meet their leakage rate of about 15 liters a minute of product gas. We actually built a machine that did 35 liters a minute, and here it is. Look how small it is. Okay, the actual reactor in here is only about 1/2 liter in volume. It's wrapped in insulation, and it's got a cartridge heater in it that can produce 1 kilowatt of heat. Okay, and then this is a heat exchanger here, okay, in which ammonia, which is coming up this tube, goes through this heat exchanger and exchanges heat with the hot nitrogen hydrogen product gas coming out the other way. So this system operates at about 700 C inside, but the ammonia coming in is cold. It cools the output gas down to ambient temperature, so it's not going to hurt the balloon, while the output gas heats the ammonia up to over 600 C, so not much extra heat is needed to dissociate the ammonia once it's inside. So this thing here operated with 1 kilowatt of power, generated 35 liters a minute of gas. If you do the math, the theoretical amount of lift gas we could have produced with 1 kilowatt would have been about 38 liters of a minute of gas. So this thing was actually 90% efficient in using thermal energy to convert ammonia into nitrogen, hydrogen lift gas. So we use this, and we use this to inflate a 1,200 gram latex balloon, and we took a photographic payload up to 107,000 feet, where it caught the jet stream, and it actually took off at over 100 miles an hour towards Kansas before coming down and being, we tracked it, we recovered it, we took photographs from altitude on the way. It was a great experiment. So this thing here is a small prototype, 1 kilowatt system, powered electrically, fine for maintaining the flight of a balloon once aloft. Okay, under the aerostat gas generation system program, we'll not only build a larger one of these, we're going to build a combustion powered one, powered by about 30 kilowatts, which is basically 100,000 BTU propane burner, and we're going to produce over 700 liters a minute of gas, sufficient to launch an aerostat or rapidly produce lift gas for one aloft, or they could be teamed to launch an aerostat more quickly. So anyway, that's the aerostat gas generation system, and we hope we'll have a chance to develop it for you. Thanks.